Alright, in this video I'm going to go over the exam 4 review in detail. So let's go ahead and get started. So let me put some graphs on here. So first of all, if you look at this first graph on A, it goes through 0, 1, or actually I put that backwards. Should say 1, 0. Alright, so first of all, that's a logarithmic function. In fact, this is the kind that has a base that's greater than 1. And notice our asymptote's at x equals 0. So that would be letter I, the first case here. I'm going to do an example. Y equals log base 2 of x would be a logarithm with a base greater than 1. And the way we learn how to do this is we wanted to switch forms first. So it'll be easier to pick points now. And with logarithmic functions, we're going to set up a table and let y be negative 1, 0, and 1. And so if I plug in 1, I get 2, because 2 to the first power is 2. If I plug in 0 for y, I'll get 2 to the 0, so x is 1. And we know that this, if I plug in negative 1, I should get the reciprocal of what I got when I plugged in 1. So it would be a half. These two are always reciprocals, whether it's exponential or logarithmic functions. And so the graph looks like this. And so this is the typical graph of a logarithmic function that has a base greater than 1. And again, the key point there is 1, 0, and you have an asymptote at x equals 0. Let's move on to B. So notice here we have a key point at 0, 1. So this has to be an exponential function. But notice this is not exponential growth, or it's not increasing, it's actually decreasing. And so this is the case where B, or base, is between 0 and 1. And let me just put in the asymptote there. Y equals 0 is our asymptote for an exponential function. And so this is case 4. Where it's exponential and our base is between 0 and 1. So again, I'll do an example here. For example, y equals 1/2 to the x power. So here we want to make a table where we choose x to be negative 1, 0, and 1. And when you plug in 1, you get a half. When you plug in 0, we know anything to the 0 power is 1. And when you plug in negative 1, you should get 2. Again, these are always going to be reciprocals. And of course the graph is going to look something like that. So you can see the decreasing nature of this graph. And let's go ahead and move on. So let me put in the graphs here. So for C, notice we're going through 0, 1. So again, this is an exponential function, and this is increasing. And our asymptote, it's y equals 0. And so this is going to be 3. So our base is greater than 1. And we're exponential here. So an example would be 2 to the x. Y equals 2 to the x. So again, with exponential functions, we choose x to be negative 1, 0, and 1. And if we plug in 1, we'll get 2, because 2 to the first power is 2. If we plug in 0, 2 to the 0 power is 1. And of course, if we plug in negative 1, we should get the reciprocal of what we get when we plug in 1. And so there's your graph for the exponential function when your base is greater than 1. In this case, the base was 2. And then finally we have D, and this one also goes to the point 1, 0. I didn't label that. Let me put that in there. So this is choice 2. So it's logarithmic and the base is less than 1, or basically between 0 and 1. Alright, and let me do an example here. How about log of 1/2, or log base 1/2 of x? So again, we want to switch forms before we start choosing, before we do our table. Just easier to work with the exponential form. So again, all we're doing is going back and forth between logarithmic form and exponential form. We only have to do this when we're graphing the logarithm ones. So again, we want to create a table where our y values are -1, 0, and 1. And you should get 1/2 when you plug in 1. If you plug in 0 for y, x will equal 1. And again, we should get the reciprocal of what we got when we plugged in 1 when we plug in -1. So we get 2 here. Again, always expecting these two numbers to be reciprocals, and our graph's going to look like that. Alright, let's move on. So now we're going to graph some functions where we're going to have to do some transformations, either reflections or shifts. So if you look at and notice we're going to have to use 3 points, and we need to show the asymptote, give the domain and range for each of these. So for letter A, this is an exponential function where our base is 1/3. So the parent function would be y equals 1/3 to the x power. So here we want to make a table where we let x be -1 and 0 and 1, since this is an exponential function. And let's plug in our numbers. And so I'm going to go ahead and just use x's for this graph, because this is just our parent function. And because the base was between 0 and 1, it's not surprising this is a decreasing exponential function. So now if you look at that minus out in front of the function, we know that causes a reflection through the x-axis, which this green arrow is how I usually indicate that. And so we're going to reflect through the x-axis, so we get these 3 points. And when we draw the line, it looks like that. Now I didn't draw it up above, but if I had, it would have looked like this here. So you can see that there is a reflection through the x-axis here. As far as our domain and range is concerned, for the domain with exponential functions, it's always real numbers. But you can see on this graph there's no left or rightmost point, and so the domain's going to be all real numbers. And now there is no lowest point as we look at the range, but there is a highest point. We don't quite get to 0, so the domain or the range is -infinity to 0. Let's look at B. So here, look at our base. Again, this is an exponential function, and so our parent here is 2 to the x. So we'll do the same thing we did last time. We'll let x be -1, 0, and 1. And when you plug those in, you should get the values that I put in the table there. Now keep in mind, as I go through this, if you need to slow or stop the video and take a little more time, you certainly can do that. Let's go ahead and put in these points. And so now we just need to look at what kinds of transformations we're going to have here. Notice because of that -2, which is totally separate from the exponent or from the main part of the function, this is going to cause a shift down 2. And notice the +3 is inside with the x as an exponent, and so that's where we're going to have a horizontal shift. And these are the ones that work the opposite of what we might expect. This goes left 3. So we're going to take each of our points and go down 2 and left 3. And so that's what I'm doing here. And you end up with those points there. Notice because I moved the graph down 2, the asymptote went down 2. Going left 3 didn't affect the asymptote at all. It was just moving it down 2. So you do have an asymptote at y equals -2 here. Alright, so domain, all real numbers again. Range, let's see, this time we don't quite get down to -2. If you look for a lowest point, the y value, we don't quite get to -2, and then there is no highest point, and so it is -2 to infinity. On letter C, I'm just going to use the y notation here. because I want to, if I'm graphing a logarithmic function, I know that I need to change forms. And so now it's pretty easy to make a table to graph this. Remember, we're going to let our y values be negative 1, 0, and 1. And when you plug in those values, you should get 1/3, 1, and 3. So let me plot those points. And actually, this is our graph here. And notice our asymptotes at x equals 0. And this is the basic logarithmic function that I want you to have memorized. Notice that it goes to the point 1, 0. And this is for the logarithmic functions that have a base greater than 1. As far as domain is concerned, notice we don't, if you don't have a leftmost point, we start just to the right of 0, and then it goes forever right, so that would be 0 to infinity. The range, notice there is no lowest or highest point, so it's going to be all real numbers. Notice it's important that you show this part here going up and not leveling off, so you can see that there is no highest point. Alright, let's move on. So on 3a, we're actually going to be doing the same kind of thing here. And so our parent is a base 2 log. And again, let's change forms. And we'll pick our table so that y is negative 1, 1, and, or negative 1, 0, and 1. And when you plug those numbers in, you get the values I have there. And in fact, we should already know what a log base 2 function looks like. It does go through 1, 0, and it has an asymptote at x equals 0. So this is our most basic logarithmic function where the base is greater than 1. So now you see we need to find the log base 2 of x plus 3. So notice here we're going to have a horizontal shift left 3, which will affect our asymptote. We're going to have to move the asymptote left 3. And so it's at x equals negative 3. And if you move each of your points left 3, that will be your graph right there. Alright, let's move on to G. Notice the parent, I'm sorry, I didn't get the domain. So domain on this one, there is no leftmost point. It doesn't quite get to negative 3 though. And it does go forever right, so it's negative 3 to infinity. There is no lowest or highest point, so the range is all real numbers. Alright, on B here, the base is e to the, well, it's e. So we're going to look at a parent of y equals e to the x. And so this is exponential, so we'll make a table with x being negative 1, 0, and 1. Notice if we plug in 1, e to the first, well actually let's put in 0 first, anything 0 power is 1. If we plug in 1, e to the first power is about 2.7. You could either have that one memorized or you can get that off the calculator using second ln and just put in 1 as an exponent. And then, so that's 2.7. If we plug in negative 1, again, you ought to be able to put this into the calculator, and it's about 0.36, which will round to 0.4. And so let's go ahead and graph this. Now keep in mind that 2.7 as a base is pretty close to a base of 2 or 3, and so we know that it looks pretty similar to 2 to the x or 3 to the x. Notice it goes through 0, 1. It looks quite similar to those two. So there's our parent function. Notice the minus out in front, that's going to cause a reflection through the x-axis. And the plus 4 out there will cause a vertical shift up 4. So we know we always reflect first. So let's do that through the x-axis. And then we're going to move each of those points up 4. Now when we do that, the graph, well, the asymptote's going to have to move up 4 as well. So that's y equals 4, and let me move my points up 4. And you know what, I think I messed that one up. Hold on a second, I need to fix this one. So let's do this. So 0, -1, let's see, 1, 2, 3, 4, that one goes here. This one goes up 1, 2, 3, 4, that one will go about right there. I'm just taking each of these points at the bottom and moving them up 4. 1, 2, 3, 4. And so that looks like that. So the graph actually goes like this. Alright, let's move on. Let's see, domain. Actually, it's going to throw off my domain and range, or at least my range. So let's see what I got here. Domain is all real numbers. The range, actually I need to change that. It's -infinity up to 4, but we don't reach 4. Alright, let's move on to the last one here, letter C. So here, this is a natural log, and so that's going to be our parent function. And we want to, remember that's base e log, so it's base e to the y power equals x. That'll be our exponential form. And we know we want to make a table and choose y to be -1, 0, and 1. Since we're going to be doing the graph of a logarithm, we want to let y be those values. And so when we plug those in, we should get, similar to what we just did over in B, get 0.41 and 2.7. So let me go ahead and graph those. And again, notice that the base here is 2.7. That's what E is about. And so this base is greater than 1. It does go through 1, 0. It's our basic function for logarithms that have a base greater than 1. So now let's look at what we have here as far as transformations. We have a minus inside with the x, so it's not out in front of the function. This is going to cause us to reflect across the y-axis. And then the +2 on the outside there, that's going to cause us to go up 2. So again, let's reflect first. And so now we're going to take each of these points and go up 2. Now notice when you move the graph up 2, the asymptote being moved up 2 isn't going to change it. And so all we're going to need to do is move these points. And there's your graph. So your domain, oops, x equals 0 is your asymptote here. Your domain is -infinity to 0. Notice we don't quite get to 0. And your range is going to be all real numbers. There is no lowest or highest point. Alright. I think I'm going to go ahead and stop the video here, and then I'll do a new one, a second one.